In this quick overview video, I will show you the process I used in how I started in Fusion, then actually brought geometry over to Blender. Kind of like to quickly explore some surface splitting, etc., which is pretty fast here, and then how I brought then only what I needed back to Fusion. So let's take a look at Fusion first. Let's go to the timeline. I started with a very basic sketch, an ellipse, and then this area for the exhaust. I want to have a very nice elliptical shape. So ideally, because this is a perfect geometry, we don't want to do this with sub D or T-splines. Here we use a sketch ellipse tool, and then you see I created a revolve object. Perfect. So this is geometrically very clean, and thus Fusion there is much better. You also see I put the object a little bit higher off the ground, but nicely centered. So to bring this over, because this is a body, I can actually go 3D print, or with body I mean it's a solid. I use the solid revolve command. I went to make 3D print and then exported an STL mesh. In Blender, I imported that STL mesh. You see I adjusted the dimensions from meter to millimeters, and then Blender converted it automatically to centimeters. So my object nicely snaps into the same position where it is in Fusion. Perfect. Now in Fusion we have, because this is a NURBS environment, we have commands like split and split face and split body. We also have for solid modeling, for example, the combine. Very strong tools, but they're very precise, but require a little bit of finesse and really knowing how you have to structure your design. So they can be sometimes a little bit slower, because what we want to do first is explore quickly design ideas. We are not concerned about precision yet. We really want to be visually free, and here Blender is better for this. So I created first some very basic dimensions. So for example, a rectangle where I removed one edge to give me a dimension for the height, another rectangle dimension for the cable extension, a placeholder for the hook, left and right profile, and then here I have 3 cross sections I tried to measure, and then for example Shift D, make a copy, Control J, join them all together, edit mode AA, spacebar bridge, and there we are. So maybe this one I extrude a little bit further in, this one now maybe I push to there, here maybe I move this one down and scale it, and at the end the tip will be, let's say, 8 millimeters. This is not really a ring, so cursor to selection. I have 6 vertices, so 6 vertices please, 8 millimeter, so radius is 4. Perfect. Can move this one down, and then bridge. There we are. Super duper easy. Okay, and then we can continue playing and sculpting maybe the shape a little bit more. How does it look from the front, from the side? Okay, you see I'm not actually really hitting the profiles, because the profiles themselves look good. But when I started adding the geometry with the sub D module, everything started to change proportionally a little bit. And it's a much smoother surface than actually what I was able to quickly create with the Bezier curves. So the Bezier curves I can create a lot of flat areas, not with the sub D, because it's just point to point to point, the way how the curves flow. So the spline tool was more like an idea maybe where it could be. Perfect. So this so far looks pretty good. Now the orange hairdryer has a lot of separation lines. So I created myself some very basic geometry. A plane that will be used to split the back off. Another plane, for example, I moved this one 1 centimeter to the left. That's actually lining up with this part. I also made here a small plane, 7 millimeters for the height, so I have a visual clue. And let's take a look at this object here. The way how this one works is I have this edge fully creased. The other edges are not bevel weight, and I then edge creased the outside edges. And you see that I am using a bevel command. So I have a little bit of nice creative ability to sculpt, for example, the transition. This would be the default. So the fillet G1 or in Fusion, it would do it a little bit better, but I rather want to have more control over it. So, and instead of working with loop cuts, in this case, I simply work with the bevel command, add more bevels, adjust the profile. I only need 5 because later when I add the T-spline module, it makes it nice and smooth. Can it play also with the radius, so it's pretty great the way how it works. Okay, good. I also have here one line. You see this one perfectly runs through the center. So how did I get this one lined up so fast and easily? Actually very easy. All we do is select a midline, Shift D, Escape P to separate, go to the edit mode, make sure your 3D cursor is at the center of your world, switch to 3D cursor, SY0, there we are, and then here E and Z, and there we are, AA, E, and let's extrude this one out, select this now, move to the left, and we snap also to the boundary, let's straighten it, and there we are. Perfect. So I do not try to recreate it. Here in this case I simply use the existing geometry driven by the polygon underlying mesh to create a curvature that perfectly fits. So super easy. Okay, so I have basically most of the surfaces created that I would like to use to do my splitting. Again, we now, because this is a polygon system, while we have modifiers to create basic volume calculations, we do not have a fillet command. So that is something we have to keep in mind and imagine in here. However, material separations, etc., can be really nice and fast here to be explored. Sometimes it takes faster. So let's take a look what I have here. There you see I have one object there, one object there, there, and there, and there, and there, and there. So I split them all. And to show you something, let's see here, this one I move up. When you see they're even all linked. Again, I'm using actually clones. So let me show you quickly how I did that. First, I brought in actually my quad ball and Shift D made a copy. This I deleted, and I am just quickly rebuilding something that could look similar to the original shape. Fortunately, in our case here, it is just an elliptical form. So that should go pretty fast to be rebuilt. not 100% there. So I need one more loop cut here, maybe there. Scale it out too far to the right. Yeah, see there, I'm getting close. Perfect. Okay, let's move this one to there. So this way I built a very, very basic representation, and also the front I will cap, so I have a solid again. Will help the commands a lot. Shade smooth, and let's turn outer smooth on. Good, now we are ready to start cutting that stuff. So all we have to do now is add a modifier, intersect, and in this case, because I really want to split, I don't really work with volumes. I actually have, or should use, carve. Works the best here. Difference, there's that one. Perfect. No, you do not want to make Shift D a copy. We make Alt D a clone. Alt D and escape. And let's switch this to intersect. You see now we have A and B. This one now, we can actually add another modifier and say, please include this one and this case difference. Okay, good. Alt D, make another clone. And now here we can say intersect, and the first one we can remove. We don't need it anymore because it's just this cap. Okay. Now I would like to have these areas cut out. So Alt, no, actually not Alt D. We will add a boolean and add just this one, but difference, there we are, perfect. Alt D, and then here intersect, and the first one we can remove. But this one is actually flush with the surface. This should be recessed. So we have to use our displacement modifier. And I just made one mistake. I did not apply my scale. So I will have to use actually a pretty big value, -1 or -2. Okay. So you see we have the basic object, then we smooth it. Sorry, basic object, we offset it, shrink it, we smooth it, and then we just trim it. There. Super easy. But this is all a gray box, kind of difficult to read. So let's actually try to see what we can do with materials. So master mesh. You see, they all share the same mesh. This is now a question JSON at. How do we get different materials onto different objects? So when we create a new material, and there we see everything is being applied because I give it to the data, so the mesh data block. I want this one to go to the object. So this one gets a new material object there, and there we are. And then you can put in whatever material you want. This is maybe just only for a quick study, so I make this one simply maybe black. Okay. Can even play with the specularity. So hardness lower means it's a more blurry, soft surface or rough surface. Higher hardness means it's a nice polished surface. So let's say this one actually should be kind of like silver. So let's make this silver. This one will get a material whoopsie, sorry, new, and this one will be black, and then here object new, and this one will be orange. Okay, and the rest actually is orange there as well. So orange, go to here, and there's orange, and it should be again object and orange. Okay, so when we use this object as a link, we basically tell the software whatever mesh is in there, just make orange, basta. So we do not, or we cannot select a face now and say, well, this face make blue. It doesn't work. And you see, this is actually very fast to create quickly an idea about how something could look. Now, how are the separation lines? Here, the separation line we can't really see well because it's the same material, but here we can see this really nicely. So let's say we want to play a little bit. Let's go into edit mode, and let's select maybe these points and say, well, maybe I move this one to there, a little bit more angle. How does this look? Ah, nice, interesting, but maybe too big. Back, forward, perfect. And see, these steps work insanely fast. Then we can do the same with the handle, which is basically what you see there. So I split this part, and then even the lower part for the cable. So this was basically now everything we can do and should do in Blender. So we sculpted the nice handle easily the way how we need, and then we used the Boolean command with the carve library and surface test to quickly split the design, and then also give on an object basis some materials to see how this maybe could look like, because that now it's easier to understand maybe the size, volume, the weight of certain elements. So how do we get everything back to Fusion? This stuff I don't really need to bring back because in Fusion I have actually this. But the handle I would like to bring over. So spacebar, export, OBJ, Y forward, Z up, selection only, no modifier. And for example, here, this has actually a sub-D. This had a sub-D. This one has a sub-D. So we can easily turn the sub-D off. Here, let me bring this one back so you see it. So let's turn it off so we can select all those three we need for spacebar, export. And in this case, I can turn apply modifier on because for this one, I want the bevel and the mirror be applied. And then I bring this over into Fusion. Here's, for example, my handle. And there are now all the surfaces. The nice thing, this is all NURBS, so we can do perfect cutting now. If I want to do modifications, I can do this either in T-splines, again, same modeling philosophy as, for example, in Blender, or I can go back to Blender, refresh one particular object and bring it back, because as you see, they will always snap into the same position. Before I continue, I want to go back one step. Here's one handle. Pay attention to that this is open and it's a nice and smooth geometry. And here this one is closed, but I have all these lines. And then there's this cap stuff with all these lines. I'm a little bit nervous about it because we want to split this one along the side, and then these lines might actually perfectly line up from the side with my split surface. So what I did was I made one copy, and then in the copy I removed the faces. One of the main reasons why I do not work here with copies but with clones is, again, to show you this, if we adjust one clone, all the other clones will update. So super easy. But because I have this one built with a cap face, I just can't go in and simply remove this one, because then maybe some of the booleans would flip out. Currently with the curve this all works, but it's very easy to simply go ahead, make a copy. So Shift D, not Alt D, so it's alone. Remove the caps, and then this one we export. Because, as you can see, it's a simpler geometry. Perfect. Okay, so that was basically part one, how to do all the transfer from Fusion to Blender, then to sculpt our stuff, create the trim surfaces, which I find actually sometimes a lot easier to do than creating a sketch. Because of the sketch we can work with the line and the spline, and then it's a little bit more complicated. I find surfaces we can easily sculpt. If you see that from the side is something else than a curve or a spline, and we can always easily manipulate, add stuff to it. So as part two, now we should take a look at how do we process or approach our modeling. And you will see you might have to sometimes start something, then you will redo a few steps, and then you restart it based on maybe what you want to do, and the way also how the tools here only work. One problem we have first is actually we have a body, and then we have surfaces. So maybe first I will unstitch, chain is off, this cap there. So I have now this as an object, so an open surface, so that's good. Great. So I have the splitting, and the splitting goes through the body and the handle. But between body and handle I want to make a transition, so it makes sense before I do this, in this case actually build the B surface. So there's something else yet to click because I haven't trimmed anything. So you cut this off, and this handle, cut the inside of the top off, and then you and you stitch together. And now I can, for example, give this a nice radius there. Good. So this transition is done. And now actually it makes sense to split it. But also I have this base down here, and that's like the cable part. That one I don't want to split, so I should split it first this way. To do the splitting, go to split. We can select this face, split by this face. Okay, perfect. So let's click this one, and you see, this is still one body. So now we have to actually unstitch them out. So okay, it's just one object, perfect. Unstitch. Now we have this part separate. Great. So now we can actually go ahead and split the rest here. So this face and this face and this face by this surface. Okay, great. And then we will do another you unstitch, and unfortunately, or actually fortunately in our case, you see it created separate faces. Because before I continue, you remember here this will be offset. So it makes sense at this point when this surface is nice and raw and also not stitched to all these other parts to now create the surface offset. Again, big problem. Try to see how you can simplify problems. So in this case, it makes more sense to build this one now. Okay. Good. Now I can actually split this one with this face. Okay. And then let's do an unstitch, this one out, and now we're gonna do a stitch, you, and you back together. There's, I have one object. Perfect. Great. Here I want to cut this part's open, so nope, not you, but you, and remove these two elements there. Perfect. Trim. Let's keep this for the moment. And this one is in my way, so I hide it. Where's actually my offset surface? There it is. So, and trim you, and I just want to remove all this. So now I have these small elements there. Perfect. At this point, maybe what I will do is this one, and this one. So you, and you remove. So my scene is a lot cleaner. Because I will do a stitching, another trim. Cut this off. Trim you. Oh, did I do that already? No. Visually it fooled me. You. There it is. Okay, that one is cut off. Okay. Nice. So, how does this one look? This is all basically, that's a plastic part that's over a wire mesh. So technically speaking, this one and this one belongs together. These other two are separate. Okay, so you see, we're getting there. So let's fix the rest of the problems I have here, because I forgot those surfaces. So let's see, unstitch. Where did I do that unstitch command? There. Unstitch. Also you and you. And then here we add these two lost bodies to it. There, let's see, there's that one, there's that one. Oh, what's this one? Oh, that's the cap. Okay, good. So, maybe a little bit of detailing there. 5. Let's make a nice transition. It's nice and big. Okay. So this is, for example, now something that is ideal to 3D print and also maybe to do a rendering. Let's actually take a look at rendering first, how we can do this. So we have individual shells, but hold on, before we continue, you and you. Didn't I stitch them together? Hold on 1 second. Yeah, I did. Oh, interesting. I cannot actually select the edge to round it. Yeah, indeed. Okay, well, 1, 2, okay, there. And you know what? Nobody shall beat me. Split this one by this line. Ding. And then this one we unstitch. I kept this problem in the video, so in case this happens in your video, you start seeing world doesn't end if there's a problem. So even I want to do 2 parts. This one should go as well. Okay, so this one I will remove. So, and then I can go ahead and say mirror this and this and this across the plane. Okay, so I might need to add a plane, or we can create a plane along actually this line. Yep, this is correct. So let's go back, mirror. Along this one. Let's see, there we are, hide the plane. And then stitch you and you back together, there we are, perfect. See, works. Okay, so these parts are now ready to be sent to render. And the precision we did in Fusion, the nice cuts, specifically the fillets, look dramatically, wrong application, better than this stuff. This is very coarse, but also very fast. You see there were a lot more tasks actually here to get this done than in Blender. That's basically what I talk about. Freedom of exploration, not so good results in terms of precision. In terms of precision, very good results, but not so really fast. So this is very good after we did the exploration. So, long talk, how do we get this stuff over? Not insert mesh, we go 3D print. Can select this one. High res, yeah, that's fine. Okay. And for example, send this one out. Body. Do this one more time. You send this out. And body. Okay. Let's go to nope. Blender. Let's maybe go to here. Import STL. Where's my desktop? There. And again, I just have to adjust the scale. Whoops, wrong one. And one more time. This one, and also here. Okay, see? They perfectly snap back together. Now we can select this one, go ahead and say orange. Nope, not this way. I want it to be this way. There, and then there, and the mixer there. Zack, zack. And let's throw in Mr. French dude there. Okay, shade smooth. Maybe, so I know what is what, I do this. Maybe here I will use the orange, but now I make a new copy. Let's say this is orange flat. So, and this is maybe orange smooth. Okay, so here 0. There we keep a roughness, and let's put in quickly an area light. Way too strong. There we are. Now we see one surface is nice and flat, the other one is more glossy. So you see bringing these parts over is literally very, very easy. Let's link the materials. Let's take a look when they even have the same material. Can we see any seam? There is a seam, but in the rendering it doesn't really show up much, fortunately. That's pretty nice. Yeah, also there. Can't really see it. And there is something, a little bit of a break. So this was basically telling you now how then you can bring everything back over from Fusion into Blender, so then we can use the superior material and shading environment to create photorealistic renderings which you as the designer want. Okay, so the last thing that is left to cover is actually 3D printing this part. How could we do this? There are actually different strategies. Before we continue, however, I want to do one thing with you. So this one, for example, minus, yeah, let's say -2. Okay, let's do this one more time. View also -2. And maybe this one, I don't know if that actually will work. Ah, did it. Perfect. So why did I actually do this stuff? Well, very simple. That is a paper shell. And I don't have any material separation line, and it won't be so perfect. So adding a little bit of a material first gives you the ability to show thickness, and now also here hold on, we might actually have to do this on object by object. So hide this one. Yeah, perfect. Ching, ching. Okay, so let's go back. You and you, and you at the also on the bottom. Don't forget it there, and maybe 0.5 there. Okay, perfect. So you see then when I bring this one in, let's hide this one there, fillet this edge, and this edge, this edge, this edge, and this edge, and maybe this edge, and 0.5. Okay, now I actually have even better render meshes because the object detail level, look at that nice separation line. It comes across more refined, more believable. So I want to go to the section view because I just realized I want to double check one thing. Let's go up. Okay, how do they line up? Do they actually intersect? No, they really are next to each other. So I'm curious if we actually at this point, because we gave the object a thickness, if we now can go ahead and say handle and handle, but join, not cut. Oh, I hope I didn't crash the application. I'm going to pause this for a second. I don't know how long this will take, and then I will be back. And of course, the moment I stopped recording, Fusion was able to finish it. Unfortunately, it's not able to do the calculation, and the main problem is these two surfaces are kind of touching each other but not really intersecting each other. So the math is too difficult to figure this out. So this is not necessarily something that's a problem, but how do we now make a nice 3D print? So it's up to you now, and a little bit of super glue I think can here really help. So what we will do is the following. We have a nice shell. With the shell, that basically means we have we are not going to print like a big solid part. So all we need to do now is we can go to split body this time and say you and you, or was this actually no, the tool? Yeah, I think actually no, there, and you split There, perfect. Because we split them along the wall plane, we have nice and perfect cuts there. So if you want to print the whole part, then now you print one side, put it into the printer, print it. Once done, put it into the other side, print it. I will actually ask you just to mainly focus on the handle for printing. So for example, I will make maybe here just a line in this first sketch. So then with this line I can actually split the handle. Okay, so let's show this. It's roughly there. Maybe let's move this up a little bit. Okay, so then we will do the same. Modify split body, this one, for example, with this line there. Okay, good. Where's this object? There. Nice. So how do we do actually the 3D printing? I talked about it a lot, but I never really showed you how to do it. This one we also have to split. And now the question is, how do we later glue these parts back together? So we want to have a nice surface from the outside. So the inside, the hollow area will be filled with support. And we kind of could maybe even use the support area as a glue surface. Plus, if we have 2 millimeters, we have an area where we could put super glue down, and then we just glue these two parts together. Perfect. So make 3D print. That's the easy way to do. And then we will go to send to 3D print utility. In case you get a warning, simply do not do this one, click OK, and then it saves actually a file onto the desktop, and then we can load it into Cura. I can send it directly to Cura. And let's load the software. And then you will see how easy actually 3D printing is. Also, some students in the course in the department, they know how to use the Ultimaker. Assam knows how to do it, Carmen knows, Teresa knows. So if you have a question, just ask them. Help each other. Okay, so printing wise, this makes no sense because it's upside down. We want to rotate this one 90 degrees. It puts it onto the ground. Then there's always a progress bar, slicing. It's basically what slicing is. If I go to layers, there you see actually all the different layers. Red is the material, and the turquoise, that's the support. And then we have 119 layers, and can go through. There you see the fill material for the support, and then there the red is, that's our actual object. Perfect. You can print, no, you can print hollow. I would not do it. You can print light. For something that's like flimsy, like a shell, actually go to dense. So this was 1 hour. Let's see, it's an hour and 50. An hour, so literally no big difference. Solid, solid even the same time. So yeah, print solid with this one. Sometimes you have to be careful when you go to solid. Between lights, you have more material to print, so it can take longer. But in our case, the way how the object is shaped, actually there's literally no big difference. For the printer, select Ultimaker 2 Plus and the 0.4 thickness. I have this one set to normal. There, let's go maybe normal. That's actually for the material thickness. Oh, I see this is 3 hours. And what's this one? Also 3 hours. And then we also have high quality. So high quality is going to take a really long time. This thing already takes 3 hours. Now we will print this for ergonomic studies. You want to touch it, you want to experience the handle. And does your sketch, does your computer model, your idea, does it actually really work? Does it feel good? So for just exploring that, we can easily just print fast. Not a big deal. Okay, then you click save, copy it onto the memory stick that's inside the Ultimaker, and then you put the Ultimaker, add the card into the Ultimaker, press the dial, go to print, scroll down to the file. So ideally you want to give this a meaningful name when you save it, so that when you go into the print dialog you can easily find it, and then you press and the machine starts working. And when it's done, you just take it out. Perfect. That's everything.